The last expression is simply the squared norm, so the sum of the squares of its coefficients of our vector of our filter coefficients h of m multiplied with the noise power. So keeping the above norm of our filter vector constant, we only need to maximize the numerator of our signal to noise ratio fraction, so part here, and we rewrite our numerator from here to here, analog to our matrix formulation, as a scalar vector multiplication with h of hm as our row vector of the time reversed matched filter impulse response, and now with only one row of the signal matrix A at a time for only one convolution sample at a time. So the signal row vector is given by this, where L is the size of our filter vector.